Now let's learn about gradients. So I recommend you watch derivatives because this is closely connected. So to remind ourselves, derivative is the slope at a single point on a function. So you see this blue function is like a bit circular, and slope at this x equals 3 is represented with this red line, and slope at x equals 4 is represented with this green line. So if you find derivative of this function x squared at x equals 3, the derivative there will be 6. That's the slope. This is also repeated, reminding ourselves from what we learned, just explained a bit differently here. And so let's look at this function. So this is surface for x squared plus y squared. So this function defines this surface. So you have two coordinates, two unknowns, two variables, I should say. And so I already talked about partial derivatives. It's just, you can take a partial derivative of this function with respect to x, which means you imagine that y is constant. You treat y as constant, you take derivative of x. So just watch the derivatives if this is new to you. Okay. So partial derivative with respect to x shows the slope if you only move in the x direction. So you treat y as a constant number, you never change y. Y is no longer variable, yeah. So you just move in x direction back and forward. And then interesting thing, you can write the partial derivatives like this in a vector. So if you put partial derivative of the function with respect to x and partial derivative of the function with respect to y in a vector array like this, that's called gradient. So gradient is just a vector, or we can also say a bit less precisely, array of partial derivatives. And if you find, we already found here that partial derivative, both of these partial derivatives, so they are 2x for partial derivative with respect to x, and 2y for partial derivative with respect to y. So we put them here, 2x and 2y. So that's the gradient of our function f. And this is very important. So what does this vector tell us? This is important. This vector tells us, this is an arrow. So a vector is like an arrow. And it tells us the direction of the steepest ascent. So in which direction around you, if you're standing on this surface, in which direction is the steepest ascent? So where to move, where to turn to move forward, in which direction to go most up, to climb most in the next step, let's say. So the way neural networks learn is they actually want to find in which direction to go down most. Let's just take that as is. I'll explain why, but just know that neural networks learn by finding in which direction you go down most. And that can be found by knowing where you go up the fastest and taking just the opposite direction. And so with this gradient, you know where you go up the most, the steepest possible ascent. So you take the opposite direction. So that's why you'll see later negative minus sign. You subtract this vector to move in the opposite direction. So a long gradient vector, so if the magnitude is long, it means the slope is steep. So if you move by one step in that direction, you will stand a lot higher if the gradient is a long vector. If it's short vector in that direction, then you will not climb as much when you take that one step. The step size is always the same. The gradient tells you how much you will climb, like in that steps after that step size. How much you will change your altitude. So zero length vector means, so 0, 0 means you are at a flat spot, either peak or valley. Although maybe I didn't explain 100% well, because as you take like the next step, the gradient will change as you move. So this is just like very near the point. So this shows just like how high or low you will go, like very near the point. But anyways, you just need to know that gradients shows how to go up the most, and so you need opposite to go down most, and that's how neural networks learn. And I have this example for you where we calculate the gradient vector for 3 x is 3 and y is equal 1, so for that point. So we can visualize this x squared plus y squared function. So this in the middle is the lowest point, and as we move like away from the middle, the surface is getting higher and higher. So these arrows show like from this exact point in which way to go to like climb up the most. You can take a look a little bit. And the longer the arrow means like you will, like it's steeper, you will climb more. And in here in the middle, arrows are very short because it's very flat. So you will not actually climb that much if you move around. So why do we need this? Why do we need to know, like, if we have some function, where is the lowest point? It's very simple. Let's say you have some neural network that needs to predict number 2 or whatever the number. Let's say in this instance it needs to predict number 2. And it predicts number 4. So we find the difference. So we want the difference to actually be 0. So we want it to predict 2 if the correct answer is 2. But the higher the difference, we can take that as how wrong the neural network is. So we want to change these weights and parameters of the neural network so that that difference becomes 0. So you know that neural network has some weights. Neural network is like a function, and these weights are like x, y, z variables. And so if we define this surface as our loss function, here in the middle we have 0, and we can take that 0 to be structure this loss function such that that 0 means like the error is 0. And these x, y, they are our parameters in the neural network, like weights and biases. So those are things that change, that learn. So we want to change those parameters so we get down to the lowest point, which we kind of make it so it's 0. Actually, let's explain it with an example. So we start somewhere with maybe some random weights or random variables. We find a way down by calculating the gradient of the loss function at your current location. So remember, the gradient will point up, so we just put a negative sign in front to make it point down. So I think loss function, we don't necessarily need to go to 0. I think like it's not obligatory for loss function to have like minimum at 0. But what we do want to do is to reduce, to minimize, to make this value of the loss function go down. And so on the surface of that loss function, it's determined by our variable, by our weights and biases. So we can just see like where do we need to move on that, how do we need to change weights and biases to go down on the loss function, so to make that value of the loss function smaller and smaller. So our error, so our loss function is actually showing our error, so error smaller and smaller. But it doesn't necessarily have to be at number 0. We just need to make it smaller as much as we want. So my loss function, when we train large language models, our loss is around 1.5 or 2. So it can be any number. And if loss is 0, that means something, when training large language model, that means something is very wrong, because it's perfectly predicting everything some random person would say that it has no information about. So maybe like it's like we are using same data, it's memorizing. So loss function doesn't have to have minimum at 0, but we just always want to go down. So we take a step downhill in the direction of the negative gradient. And because our weights and biases are also like matrices and vectors, we can just subtract this gradient vector from it. That's gonna work. Because this gradient vector is showing us in which direction to move, or is the steepest descent. And I showed you in vectors lesson that if you have like two vectors, they can be in like high dimensional space, not just 2D, but if you just subtract them, this vector and this vector is actually gonna push the vector in that steepest descent direction, for example, where you want to push it. So subtraction here just works. So then we repeat, we go back to step 2, take gradient and subtract, and that's it. And repeat until we minimize our loss to whatever is desirable. But loss 0 is not always desirable, especially if there are some random things happening, like in language model. You don't know what some text will be writing, but there are some rules, so you can guess a little bit what text will be writing. That will be our lesson on gradients. I recommend you watch this, read this, and try explaining it yourself. Try again, and that's it.